We are asked in this example to find a regression equation for males and females. We're to use X as the years since 1960. So taking a look at my data, 1960 would be year 0, 65 would be 5, 70 would be 10, and 75 would be 15. And then we're given the percentages, and because it mentions that we're to use a regression equation up here, we're going to be going to our calculator to do this on our calculator. So in my calculator, I start by going to the Stat button. I want to edit, and I need to clear the data that's here. So I go up and hit clear and enter, and then I'll go over to list 1 and do the same. Go up to the name, hit clear, and hit enter. All right, so the years we're dealing with are 0, and I have to hit enter after each one of these. 5, 10, and 15. And then the percentages that we had. In 1960, we had 54%. In 1965, we were at 57.3%. And then we were at 55.2%. And finally at 52.6%. So we'll then use our Stat button. Actually, we'll quit first, so we're back at our main screen, and then use our Stat button. And this time we want to calculate the regression. So I go over to Calculate, and I choose a linear regression, and enter through these because they're all set up correctly. And we get our first formula, so negative 0.126 plus 55.72. So in my PowerPoint, that was the data for males. So our formula for males is y equals negative 0.126x plus 55.72. So now we're to repeat and find a formula for the females. And so we need to go back into our calculator, and we need to change the y data to the percentages that we have here for the females. So in my calculator, I go to Stat, I hit enter to edit, and I want to clear out list 2. My list 1 stays the same, so I don't actually have to clear that. So my first percentage for females was 37.9. And I have to hit enter after typing each one. My second one was 45.3. My next one was 48.5. And my final one was 49%. So again, I want to quit. And once I'm on my home screen, go back to Stat, over to Calculate, and down to a linear regression. Hit enter, and hit enter through all of these. And we get an equation representing the females. So we have a positive slope here of 0.73, and the value for B, the y-intercept, is 39.7. So for females, we got 0.73x plus 39.7. All right, so we'll keep those two formulas in mind as we go on to the next slide, where it actually asks us to do some questions. So it says, if the trends for college enrollment continue, when would you expect first to have seen the same percentage of female and male graduates entering college? So the first thing it does is ask us to use the graphing method to solve. And so what we're going to do is to put our two equations into our graphing calculator for y1 and y2. And we'll see where they intersect on the graph. So on my graphing calculator, I'm going into y equals, and I'll clear out what I previously had in here. And so I'm going to be typing what I had found for the males. So I had negative 0.126x plus 55.72. And then for the females, I had found 0.73x plus 39.7. All right, so I then have to set up my window in order to see this graph. So I'm going to go to my window. And in my window, the data that we had gone from 0 up to 15 years. So I'm just going to go a little past that, and so I'll go from 0 to 20. And then when I think about the percents that we had, because the percents were the y values, the percents for the women started out lower. So they started at 37. So let's go a little below that at 30. And then the percentages for the males went the whole way up to 57%, but they had a negative slope, so they were coming down from there. But I want to go a little above that just so I can see what's going on. So I'll go up to 60. And so all of the percentages that were in our original data are captured between 30 and 60. So I'm going to take a look at my graph. And I see a lot going on here. So the blue line with the negative slope is the regression equation that we found for the males. The red line with the positive slope is the regression equation that we found for the females. And if I go back to my y equals, I see that my stat plot was turned on. And so it plotted the data points too. And the data points that we had in were the data points for the females. So these blue dots that we're seeing here are the data points that are surrounding this red line. So we can see that they weren't perfectly linear, but they probably were random amounts of change, and therefore our line is a good approximation. I also see this first point right here, the first time that the two were equal. And so I can find that using the second and trace button. That is a point where these two graphs intersect, so option 5. And that is my first curve, my second curve, and then I would not have to guess, but I'll be nice. So I'm moving my cursor right where I think it is, and I do hit enter so that it calculates the exact value. So 18.71. So the two intersect at 18.71 years, and the percentage here is 53.36%. So use the graphing method. So we found this ordered pair 18.71 and 53.4%. So we have to think back to what our data was, and this first number was the years, specifically years since 1960. And the second number was the percent. So if I take 1960 and I add to that approximately 19 years, I would have 1979. So my prediction is that the males and the females would have the same percentage in 1979. Okay. Down here I have some notes, and this actually occurred in 1980, so my prediction was really rather close. And then the percentages fluctuated, but they stayed very close to each other throughout the 80s and 90s. Once we hit the 2000s, we had more female graduates than we did males. 2008, for example, males were at 66% and females were up at 72%. Now, we're asked to do the same problem again. This time we're asked to use the substitution method. So I want to write down my two equations that I had. So we have y equals negative 0.126x plus 55.72. And that was the equation we had for the males. And then we had this equation y equals 0.73x plus 39.7. And that was the equation that we had for the females. So when we do substitution method, we replace a variable with a formula for it. So in this first equation, I have a y all by itself, and the second equation tells me that y is equivalent to or equal to this formula. So I'm going to take this formula and substitute it into my first equation. So putting the two equations together, I'd have 0.73x plus 39.7, and then continuing equals negative 0.126x plus 55.72. So truly, we have substituted this amount into the first formula for the y value. And what I have left is something where I can do the algebra. So the first thing that I did was add this to both sides. And so doing that, canceled these guys. I have right here 0.856x. I still have that plus 39.7, and that's equal to 55.72. So then I can subtract the 39.7 from both sides. And doing that allows these to cancel. So I have 0.856x is equal to, doing this math on my calculator, 16.02. And so finally, I divide to get x by itself. These guys cancel, and I have x equals to 18.7, and there is more decimal to that. We've seen that 18.7 before because we had it up here. That 18.7 is the x value, which we had originally defined as years since 1960. So if we round to a whole year, that's approximately 19 years and gives us that same 1979 that we found before. So two different methods that give us the exact same answer. One of those methods is all in the graphing calculator, where we graphed and we found the point of intersection. The other method, the substitution method, is all algebraic, all by hand. And it's called the substitution method because literally we took this amount and substituted it into the formula for the variable y, because y is equal to both of those expressions.